So this is a lecture. So what we previously saw was we saw about the scalar quantity and we saw about the vector quantity. So if you are coming to this video without any knowledge of previously, the scalar quantity are the quantities which have only direction like a speed, and the vector quantity are the quantities which have both direction and speed. So direction and not speed but direction and magnitude. So it's simply taking an example of by representing a aeroplane in a Cartesian coordinate system. So this is a y, x and the z, and you're having a position vector which is OP, and this position vector is given by as the vector OP, and the direction of the vector is given by the unit vector OP. So if you are saying that the OP vector, the velocity of a plane moving in the OP direction is 100 km per second in the direction OP, so this is a vector and this is a velocity which can be represented by vector, but you are simply saying that the speed OP or VOP is 100. So when you're considering only the magnitude, you are not saying that in which direction it is moving, or simply you can say it as a speed without any information about the plane which is moving in OP direction or anywhere. So this is a speed of a plane X, but this is a speed of a plane X which is moving in the OP direction. So when you are having both direction and magnitude, you are dealing with the vector quantity, and that was a scalar and the vector quantity which you studied. So again, there is possible to have the representation of these quantities, and to represent that quantities we could use something like the Cartesian coordinate system. So to understand the Cartesian coordinate system, so this was invented lately, and this is a tool which we are going to use to solve problems related to vector. So you can solve the problems related to vector. Also you can use this tool to represent vector. You can use this tool to find out the unit vector, etc. So any vector can be represented in a form which contains two kinds of vector, a component vector and a unit vector. So we will see in detail, but simply going that if you are simply considering a plane, so if I say the table on which I am working right now is a plane, then I can say that this plane I can divide into two regions, two way. In one which I can say that this is my x and this is my y. So by having two coordinates, which is the x coordinate, so x and y, if I write it very specifically, x and y will be called as my coordinates, and this is in a plane, and this is the representation using the Cartesian coordinate system. So it's possible to represent any point in a plane using 2 points x, y, and you can do this by using the Cartesian coordinate system. But now I am going into my space. So if I'm considering one more axis, z, one more axis z, then what you will get is that you are seeing that the x and y are perpendicular to each other, yz is perpendicular to each other. So this kind of a representation is known as a Cartesian representation. So again, not going into much detail, as you can see, this is a right-handed Cartesian coordinate system. So I will draw this full idea again in the next diagram. So while drawing this full idea again, you can see to just represent the z as a perpendicular line, and you can represent the x so these both are perpendicular, and again I'm having one more line. So this is a way in which I'm representing what is known as my y, my x and my z. So again, representing it another way, writing just simply, it is possible to draw it in this way also. So this is my x, this is my y, this is my z. So both, if you go this side, it will be positive, negative. So this is so to write it, this is a Cartesian coordinate representation, Cartesian coordinate system to represent any point in space. So how I will represent a point known as 1, 2 and 4 in space? So one of the simple ways, that if I am considering that my x is 1 and my y is 2 and my z is 4, so I am having a point with this, to represent a point with these coordinates in space. So my x is 1, so this is my 1, and my y is 2, so this is my 2. So when I will join this both, when this both will intersect from here, so this is my representation of 1, 2 in plane, that is x and y. And again my z is somewhere something like 4. So if I will draw that z height above, and this will intersect, and then I can say that this is my x, y and z, and this is my point in space, that is 1, 2 and 4. This is how I am representing any point. And when I am drawing a vector from the origin to the point P, or when I'm drawing a line from origin to the point P, this way it's not up to scale because I'm just using this way to be accurate. It's coming from the origin. So if I am drawing a line OP, then this is a position vector from the origin to the point P. So this kind of vector is known as the position vector, and the position vector will be used to give the position of any point in space, position in space with respect to origin. So that's what you saw about the position vector. So that's how you are representing any point in space using the Cartesian coordinate system. So now how to write that? So coming to the point of what we saw was a point 1, 2 and 4, and we represented that OP, what we found was OP was a position vector in space. So how to write or represent a vector? So suppose I am just taking the case of a OP. So it's simply saying that the OP vector will have something known as OPX, which is the magnitude in the direction of x, and this will be added by a unit vector in direction of x, and plus there will be OPY, which is a magnitude in direction of y, and should be added by a unit vector in direction of y, and there will be another vector which is OPZ. This is not vector, but this is best magnitude. There's nothing like this here. So AZ. So this is how you will represent a position vector in space. So again, this together, what it is known as, this is known as the component vector of AX in the direction of x. This is the component vector in the direction of y, and this is the component vector in the direction of z. So if I am having a vector A, so simply to having a vector A, it can be represented as AX and the direction or unit vector in the direction of x, and AY, with the direction in the or the unit vector in the direction of y plus az with the unit vector in the direction of z. So what all I have found here, so these are my magnitudes of respectively in direction x, y, z, and this together is known as a component vector in direction a. So a vector is made up of two things. Vector is the summation of individual component vector in direction x, y, and z when you are saying it for the Cartesian coordinate system. Again, a vector like OP can be written as OP, the magnitude of the vector, and the unit vector. So this is the other way. So we will see what a unit vector is all about. So if I'm having a simple vector A, it can be written as AX by the unit vector plus AY by the unit vector plus AZ by the unit vector. So to take the unit vector of A, I will have to is equal to the vector itself. So unit vector will have a cap on top of it. The unit vector is and divided by the magnitude of that vector. So the magnitude of the vector can be found out as the square root of each of the components, ax plus ay square plus az square. So you are taking the square of this, and that's how you are finding the unit vector. So any vector can be represented in much simpler form, like a vector can be represented as the magnitude, that is the magnitude, you are taking this here, magnitude into the unit vector. So that is the other way to represent any vector. So that what you saw about unit vector and how to represent the vectors. Again, just bringing in more understanding. So if this was a x coordinate, this was a y coordinate, and this was a z coordinate, and what you found was this was a ax, ay, and az. So if you want to find out ax, so my unit vector ax will be my vector a x divided by the magnitude ax. So if you are having a vector, the simple way, like it would be how it will have 1. So to find out that why this will be 1 is simply, if you are having a vector which is only going in the x direction, so it will be can be represented as 5 0 0. This is a simple example of having a point 5 5 0 0 which you are representing on the x-axis. So this can be written in the vector form. So suppose this is a vector, this is a point A here, so this is a vector OA. So you can represent the OA vector as 5 AX plus 0 plus 0. So again, to find out the unit vector of this vector will be always equal to AX. So how you can find that is that if you are doing a magnitude of OA, what you will get is square root of 5 square plus 0 plus 0, which will be equal to 5. So to find out the unit vector of OA, OA will be like OA unit vector will be equal to the OA vector. OA vector will be 5 AX, and again divided by the magnitude, which is 5. So you are getting the unit vector itself here. So any vector in this direction will be the unit vector with the value 1. So that's what you have found out. So for all each of these axes, a unit vector can be given by ax, ay, az for the x, y, z axis respectively. So again, what we saw so far was vectors, and we saw Cartesian coordinate system for representation of vector. Again, the Cartesian coordinate system which we saw was a right-handed system. So this is x, this is y, and this is z. So I'm moving from x to y. So what is happening is when I'm moving from, this is my screw. So if I'm taking simple example of a screw, and if I'm moving from x to y, and if I'm rotating my screw, then if I'm rotating it this way, then it will move upwards. So my direction of my screw will be always towards the direction of the z. So when I'm having a Cartesian coordinate system in the clockwise direction, and by applying the right hand screw rule, the screw moves in the direction of the z, then this kind of a coordinate system is known as the right hand coordinate system. So this is what we have seen so far. So again, you can go through the references or the books suggested by university, colleges, etc. for more detailed understanding. This is just the basic understanding of the full concept which I wanted to demonstrate to you.